A very good morning, dear participants. I welcome you all to this final day of this 1 week online faculty development program on integrating Autodesk Fusion 360 in engineering subjects. I hope you have learned much from these few days. So for today's session, we will continue with the simulation of static and stress analysis and thermal analysis. Yes, sir is here with us. Without wasting much time, I would like to hand over this time. Over to you, Riya, sir.
Very good morning, Daniel, sir. Thank you, and then good morning to all. So let us start the today's session with the thermal analysis, basic thermal analysis, and then let us move on to the thermal stress analysis. Sorry, let us start with structure analysis. So before getting into the analyzing part, let me share my screen and then let me show about the generated design. Actually, just now I solved my issues, potential issues, and then I started generating the designs which we already created. Excuse me. Okay.
Sir, we are unable to see your videos.
Sir, video, I have some problem here, network issue.
Okay, okay, sir. No problem.
Wait, sir, wait. Let me connect. Okay. So what I did is actually just I clicked the generate option. See here, the generate option is there, right? The generate option is there. So if I click on that, it started to generate our designs. So actually it is running. See, for knowing about our job status, we can see it on the top actually. So here the job status is there. Just click on here and then view job status. So the generated design is running so far. Actually, only 5% is over. So it is getting solved actually. Okay. So just now I clicked the generate icon, generate button. Okay. So only 5% is over. So if you need to explore so far what we what it is achieve means go ahead with the export option. Just click on export generative results. See, it is getting generated. It's not get over. So that you can sort by mass or it can sort by volume, whatever it may be. So this is actually processing status. Okay. So let it complete. So let us wait until that. Okay. Excuse me. I think somebody called from our FDP only. So that's why I attend the call actually. By mistake, they are called.
Okay.
Okay, so let this complete actually, no use. So meanwhile, we will move on to the next portion. So an untitled option is there. So wait, let me open a structural thing. So for a moment, I'm just sharing my screen actually. So let me open a file for structural analysis. Let us open a connecting node assembly. So this is Dave file, right? Okay. Okay. So this is the connecting node assembly. So now we have to switch over to the simulation part. So here we're going to do some analysis on this connecting node. So just for switching over to the simulation, we have to change the workspace. So here for changing workspace, you can click over here. And then here there is an option called the simulation. So this here you can do kind of structure analysis, thermal analysis, what are the analysis that you can do it actually. So just click on here, simulation. See a new steady dialog box is gets appear. A new steady dialog box is get appear. So here you can see what are the analysis you can do it in Fusion Resistance. Static stress analysis, model frequencies, electronics cooling, thermal stress, structural buckling, non-linear static stress, and then quick static event simulation, quasi-static, quasi-static event simulation, dynamic event simulation, shape optimization, injection molding simulation. So these are the things we can perform it over here. So let us start with the static stress analysis. So basic kind of thing actually. So before getting into the static stress, so let us check about the settings. So here the settings dialog box is there, right? Let me click on here. So what kind of settings are there? The study is named as study one, that is static stress. And then remove rigid body modes is deactivated. So then automatically the rigid body will be there actually. Okay. Then go to the mesh. So in mesh, by default, it is in model based size. Let us change it to absolute size. Let us change it to absolute size. So here, let me give the value in inches. So let me give value which is 0.1 inches. That it may be of 2.4, 2.54 mm. So initially it was 10 mm, right? So even we can give it as 2.54 mm itself. But here in this example, let us go with not SI units. So that's why I mentioned as 0.1 inches. So we go with inches only. So let us go with inches. Just click on back option. Okay. See that what are the settings we have did? General, we didn't do any changes. Only on mesh we had did changes. Instead of model based size, we have changed it to absolute size. So the 0.1 inches. The size, if you keep on reducing means automatically the accuracy will also get increased. If you keep on decrease the size of the mesh, the accuracy of the result it will more actually. The precision of the result it might be more. The accuracy would be the same, but the precision of the result would be more actually. So that's why here we are changing from model based size to absolute size, and then we are giving the size value. So instead of 10 mm, we are given only 2.4 mm. We had mentioned that in inches, that's all. Just click on back, and then let me click on create study option. Okay. See, now it is converted to simulation. Units or different options are there. As like we are seeing in generative design, here also the step-by-step icon would be there actually. So first we have to create study, and then if required, we have to go with simplify the model, and then we need to check the material and what material for what material we have to do analysis. Next we have to give some constraints, and then we have to apply loads, different load conditions actually. So here see, you can apply structural load, linear global load, so the angular load, and then in by default the gravity will be there, and then the contact sets. So we have to give the contact sets, how the contact set might be, as like that we have to give it. And then this it may be the model view, mesh view, and then degree of freedom view. So degree of view means degree of freedom view actually. And then manage. So here you can get the settings options and all. So what are the settings you have to do here? You can do it in manage. Later we have to go with the solve. So after checking everything, we have to go with the solve. So here you can, after that you can go with the results also. Actually, Fusion 360 is incorporated the answers also. So if you need to do some study on answers means that also it is possible. Export study to answers setup actually. As that also you can switch over to the answers and then do the analysis research part where you can compare the results. And then here the result part, final results. So how it can be generated. Right? You can view the results as like that. Okay. So let us do one by one. So here we do not need to go with any simplify. Here only cutting rod is there and the two pins. One is larger pin, another one is a smaller pin is there. So here we going to apply the loads on the pin. So we are going to study on two cases. That is on first case, excuse me. Uh, so meanwhile, I'm just to switch off my video, because if the video is on means my bandwidth will be reduced. So that's why. Sorry. So here we're going to apply the loads on the larger pin. So here in first case, we're going to apply the load on only larger pin, and then the smaller pin we have to fix it. Because this area only going to be rotate, right, actually. So this only has some motion. So the smaller pin won't be get motion actually. Okay. So we have to consider that it as a fixed one, and then we're going to apply load on one pin. So that is a first case. The second case, we don't going to fix this one, the smaller pin. So instead of that, we are giving equal and opposite load on this pin actually. So what the load we're going to apply on this larger pin, the same kind of load you're going to apply on the smaller pin, but on the opposite direction. So that is the second case. So we are going to apply two cases. So first case, the smaller pin is fully constrained. The second phase, the second case, we're going to apply the balance load on the smaller pin instead of giving constraints. Okay. Okay. Let us go with the first case now. So first we have to, we already created the study, and then in this model we need not to go for simplify option. So I'm just skipping this one actually. So then you have to check the materials. So for checking the materials, just click on the material tab, material group, and then click on the study materials. So if you click on the study material means you may get a dialog box. So just check whether the connecting rod is in aluminum and another pins are in steels. See here the connecting rod is in aluminum and the larger pin and then small pin are in steels actually. The connecting rod is in aluminum and then larger and small pin are in steel actually. So and then actually this is the design material. This is the design material and these are the different components. So the material of the design of the same component is displayed here. And then this is the study material. So here it is, this is the material we're going to note down because here what it is mentioned as same as model. Same as model means the same as the design material. Same as the design material. So the design material is used as a model actually. Here it may be something. These are the materials used in the model actually. So that's why here it is mentioned as a design material. Okay. So if you need to change, see, I had design in aluminum, but I need to check with some stainless steel as well. That means that you can change it like here. But in this case, it is not needed. In this case, it is not needed because connecting rod is an aluminum only, larger pin, smaller pin is steel only actually. So let us just click on OK. So now we have checked whether the material is applied or not, and then it is based upon the real-time material. So we have checked that. So everything is okay. Just click on OK. So the material is completed. So if you need to check the material, here this is the button that you can change it, and then even you can check whether here also. See the different materials is used, and then the study material here there some pencil based icon the edit icon is there. If you click on that means you may get the same dialog box, and then you can check it. Okay. So we didn't change any material of this particular model. So next what we are going to do is we're going to give some constraints. We're going to give some constraints. Just click on structural constraint. So by default it is in fixed. So anyhow we're going to we're going to apply the fixed constraint only on this smaller pin. So how we going to apply the PC and then the fixed constraint is going to be applied on X, Y, and then Z. X, Y, and then Z. All the three axes is constrained. So if we choose this face and then this face. So just rotate with the help of shift and then central scroll button. Select these two faces. These two faces, come to the home. So just we had fixed the all the three faces of the smaller pin. All the three faces of the smaller pin. Just click on OK. Now let us go to the again constraint option. So we just right click see here there is an option called repeat structural constraint. So if you go in this, actually this is maybe called as a canvas. So just right click. So previously used commands that would be displayed here. So in this option, repeat structural constraint is there. Let me click on over here. Okay. And then here we're going to fix the Z direction of the larger pin. So what is the Z direction? So this is Z axis. You may see the view cube. So this axis is going to be act as an Z axis. That constraint is going to be applied because it should not be moved. It should not be leave on Z axis, right? So that's why we're going to apply constraint on Z axis for the larger pin actually. Let me unselect the UX and then UV. Here we don't go we don't go to apply the constraint on UX and then UY actually. So only on Z axis. Let me choose both the faces. Sorry. Actually here we have to apply on the vertical edges. That is, this should not be moved on Z axis actually. So what I'm going to do is just let us expand the model component and then hide the connecting rod. Hide the connecting rod. See here the connecting rod is there. Let me hide that one. So actually here the larger pin is splitted into two halves for applying loading for applying to apply loads. Here it is splitted into two halves. That's all. The faces one is splitted. Okay. So just select this edge and then this edge. So this edge and then the opposite edges also. So all these four edges is going to be constrained on Z axis. So this should not be move on this axis and then this axis. Okay. So that's why we have give constraint on Z axis. And then again go ahead with just hide the connecting rod. Again go ahead with the constraints, structural constraints. And then choose the circular edge, these two circular edge. So this should not move along y-axis. Y-axis is vertical axis. So it should not move up and down actually. So in this view, it should not move up and down. So we have to constrain this on y-axis. This object should not go towards up or towards down. So it is constrained with respect to y-axis. Just click on OK. And then let us hide the large pin and then show the connecting rod. So in connecting rod also we have to apply some constraints. What the constraint? It should not move on y-axis. Here also the same circular edge. It should not move on y-axis. Okay. So let me choose on this and then click on unselect the UX and then use it. Select the UY and then just click on OK. So here we had applied all the constraints over here. So now switch on the larger pin. Okay. So now the constraints are over. So we had created the study, check the material, and then we had apply the constraints. So now go ahead with loads. So here we're going to apply the structure loads. So normally force. So let us apply on this face. Let me select this face and then with respect to on both the faces, both the sides. It has to be selected actually. Let me choose home view. And then here I have to give the direction. See, let me choose the vectors. So the direction it should be away from this smaller pin, right? So away from the smaller pin. So then the direction should be on x-axis. See here in YouTube you can see it actually. So away from smaller pin means that should be on the x-axis. So apply that should be on my negative direction. So actually if you apply the x direction positive means it should be on towards smaller pin, but it should be on away from the smaller pin. So let us give the direction value for giving the value, by giving the value in negative, you can give the load on negative direction away from the smaller thing. See here, it is exactly mentioned that. So, but before that, actually, I have to change the units to change into LB. So here I'm going to give the value in pounds, not on Newton. So let us give, excuse me. Okay, fine. Okay, here we had applied the minus 2000 pounds. So just click on. Okay, so in this way we can connect that. We are applied the loads. So now the contact loads are over. Next, we have to go ahead with the contact sets. Just click on the contacts and then go ahead with the automatic contacts. So by default, it is that it has some tolerance that is 0.1 mm. So that it has to be there actually. Just click on generate. So that should be some tolerance. Just click on generate. So if you need to change, that means that you can do it actually. So click on automatic contacts. Even so here, let us apply some inches actually, 0.004 inches. Just click on generate. Because that is higher tolerance, so that's why I mentioned as like that. And then here, every body is contacted in rigid manner. Every body is contacted in rigid manner. So we have to go ahead with check that one actually. So go ahead with contact and then choose the manage contacts actually. See, it is on bonded. So one component and another one face and another face, it would be on bonded actually. So, but it should not be bonded. It should be on separation. So I have to change the contact type it as a separation. So for that, I have to select all the contacts. So let me select this one. Let me select this one. And then by using the shift key, I'm select the last one. So automatically all the contacts are get contacted. So now I have to change the contact type to separation. So from here it is bonded actually. I am just changing into separation. See, automatically all the contact type change it to separation. Just click on OK. So now the contact type between one body to another body is changed to from bonded, it is changed to separation. So it should not be bonded. So that's why we have mentioned it as a separation. Okay. So that's all. So here the contact sets is also applied, loads applied, structural constraint fixed, materials applied, everything is over. So just go ahead with pre-check. Just click on the pre-check. There are some warnings. There are some warnings. What is the warning there? Model contains only partially constrained groups in the load case 1. So it would be there because we can't say it as a fully constrained, right? So that would be there. So just click on close. So just Next, click on solve. Just click on solve. So while click on solve, the extension it is active. So status is there. So just click on and then click on solve one study. See now the static stress is started actually. Sending is over. Solving is started. So it's started with 3%. So meanwhile, you can close this job status. Meanwhile, you can close this job status. You can see that in top. So here job status is here. Just click on here. View job status. See, you can see the job status here. Even I can view our generative design. How much actually it is completed. So we can review that. Okay, let us review after solving this static what the structure analysis. Let me close this one. Okay. So now what I'm going to do is just I already said that we're going to be solve this problem in two cases. So the second case. So we are moving to the second case actually. So just right click the study one. Right click the study one. So here clone study is there, right? So just click on clone study. The same thing we have did in generative design also. So just click on clone study. So this is the static study 2 is there. Now what are the thing we're going to do here it is. So first expand the load cases. Only we're going to change the load cases, right? So just expand that one. So before changing the load, that is before applying the balance to force on this smaller pin, we just remove the constraints. So just expand the constraint. So which constraint is fixed constraint? So this is the constraint which is fixing the smaller pin. Just right click and then delete. Just right click and then delete. So now the constraint on the smaller pin is removed. Now let us move on to the loads. One load is there. I'm going to apply another load actually. So go ahead with the same structure load. Forces. Let me choose these two forces or phases. Here we're going to apply equal and opposite load. Just go to the vector, the same x vector. Change the unit to pounds. There we are given 2000 value. That is minus 2000. Here we're going to give plus 2000 actually. That's all. Just click on OK. So we had removed the constraint and then we had applied the loads. So we had made the necessary changes. So here also you can click on this all. Automatically this also going to be added in our job status. So just click on solve. So before that, go ahead with the pre-check. So the same constraint, the same error. So we can skip that one. There is no issue on that one actually. So just click on solve and then choose the static to study to static stretch. Just click on solve one study. So this also going to be added in our job status. See. So these also added. So we had sent two analysis. We had sent two analysis. So let it complete actually. Okay. So let us give some time to complete. Just close off. Excuse me. So sorry for the interruption, sir. So here we are gave two, right? So let us go to the job status. The study one is completed actually. So just click on the results. So here by default some factor of safety is there, load case one is there actually. So by default the load case one is active. Load case one is only active. So let us change to displacement, the result of the displacement. Let me click on the displacement. So where the displacement maximum occurs on the, it is occurred on the larger pin because we already give restriction on for this smaller pin. We had give it as a fully constraint. So that's why it shows in blue in color. And in the maximum stress, we already know actually. So it would be occur only on larger pin. So you can go with the check and analyze about the stress also. So where it is lower actually, so here it is lower, and then maximum it might be on the smaller pin only because here only we have fixed the smaller pin, the loads are automatically the stress will be created at here only actually. So see where we can get the maximum stress and then minimum stress. So here what I had did is here static screw stress. One thing I forgot to do it actually. Now see it is actually failed. Study 2 is failed. What mistake I did is let me activate this one. Let me activate this study stress, static stress. So just manage the settings here. So we have to remove the rigid body modes. So for this only we are okay. Now go with the pre-check, the same. Let us go with the solve again and then choose the static study 2 static and then click on solve and study. So now let us wait for the process. Okay, meanwhile, let us go to the generative design part. So here, actually, it is completed now. See, for exploring the results, just give export generative results. See here, what? Let me sort it out based upon the material. So what are the materials? ASI titanium. So these are the recommended outcomes. These are the recommended outcomes. If you need to compare this one means just click on the compare option. So these are the different options. See, these are structural 31 component. So here by default it is selected. So what is the material of this one? Titanium 6AI. If you click on this, so this is also titanium. This is also titanium. This is steel. So this part alone steel. All these three are titanium. So in by looking the material itself, we can see the difference between the steel and the titanium actually. And then if you click on here, actually here the cost and all will not be appearing actually. So if you click on here, you may see the volume of that one and then mass and then maximum one versus stresses, factor of safety, minimum factor of safety. If you click on here, the mass it may be varying. See here, this is 1.41. and then this is 1.39, this is 1.452, this is 1.874. It's higher. Actually, we have generated the design to reduce our mass actually, to reduce our mass. See, this is the component. So all these edges are going to be fixed with some fastness. So this is the area we are going to generate, sorry, going to fix on the pin actually. Just click on finish. Outcome view. So this is on study one actually. Visual similarity manufacturing method. So whether it is unrestricted or additive. So we are going with only additive manufacturing. So let us uncheck this one. So if you uncheck this means automatically some of the model idea it would not be displayed. A lot of model ideas are displaying here. If you uncheck this means some of the model idea it would not display. The model which is used to create in the manufacturing methodology of additive manufacturing, that only it will display actually. Only the additive manufacturing method only display, all other it will be removed. And then material, let us remove the steel. Still some of the materials are removed. Let us remove the stainless steel also. So if you need to go out with apply with titanium means only three outcomes are there. Outcome number 6, outcome number 7, outcome number 8. Compare these recommended outcomes. Actually this 6 and then 8, 5. 6 and 8 is there actually. So here number 7 is not there because that is also titanium. It is not recommended as like it shows. Might be if you select this item means you can see the mass of that one actually. What is the mass? 1.406. 1.406 is the mass. If you click on 6 means 1.41. So it is higher only actually. Sorry. If I need to compare all these three, if I need to compare all these, let us see that. Let me click on finish outcome. So just select this one. Select this outcome. Select this outcome. See here, open the comparison view. Let me click on the comparison view. So all these three are getting visible. Let us use some other view actually. Sorry. Even you can see in a table like view structure actually. This is 6. So for outcome 6, volume is 8.81, mass is 1.41. Outcome 7, 8.78. One misses stress is same for both 6 and 7 for all the three. See, actually here the mass is not reduced, 1.452 actually. The outcome 8, the mass is 1.45, but outcome number 6 and then outcome number 7, it is 1.41 and then outcome 1.406 actually. And then the displacement, maximum displacement in inches, see for this one it is higher while compared with the outcome 6 and 7, 6 and 8. Out 6 and 7 is higher while compared with 6 and 8. See, by considering all this only, here it shows some recommendations. See, just click on. See, the recommended outcomes are 6 and 8 as like that only it shows. So we can choose the 6. We can choose the 6. We just design from outcome. Just click on create an editable. You are going to create, sorry, cancel it. So just unselect this one. So what are the things you're going to create actually? So you have to compare the each and every models, and then you have to create the design. You have to incorporate that design, right? So for that you have to choose any one of the design. So let me choose outcome 6. Let me click on outcome 6 and then click on design from outcome. You are going to create the design from these outcomes. Yes, of course. Click on just OK. So the generative model, it's again start the outcome 6 of 31. The 31 outcome there actually we're going to process that part alone. We're going to generate the model for that particular object alone actually, that outcome alone. So just click on design from outcome. You may get the model for that particular outcome actually. Okay. So here also it's getting processed. Just click on project. So let it be completed. Let it be completed. So let us wait for that moment. Okay. So meanwhile, let us go to the connecting node assembly. Now our study 2 is also completed actually. So just go ahead with the stress factor. Sorry, first let us go with the displacement factor. See, this smaller pin is getting moved away actually because we had applied force, balanced force. We didn't restrict this one. We remove all the constraints on this one. Okay. So only the displacement it's occur maximum at the smaller pin. So if you go for stress also, you may see the one versus stresses are there actually. So like this, you can compare the results. And then if you need to save some of the results, means that also you can do it actually. See, let us activate the study 1 static stress. Let me click on this one, activate. Just to click on this round. Let me click on here. The study 1 static stress is activated. Let me complete the finish results, or else we can go with here itself. See, the result tools icons are there. Report option is there, right? Let me click on here. Okay, I need to generate the report for only study 1, or let us go for study 2 also. Okay, let us select the study 2 also. And then let us add opposite camera view, mesh should be there, settings should be there, material would be there, everything is there actually. Okay, for study 1 also, let us include all the things. So now go with the general option. Let me click on the general. So because why I'm clicking on general means where it has to be get saved. So that thing we have to very cautious on this one. So here actually this is logo, report properties, project properties, studies. Click on generate option. Here we can do it actually. So click on generate. So click on generate option. After selecting all these things, just click on generate. So here where I have to create that one. So let us save to a project in the cloud itself. So studies report is there. So it would be saved in the form of HTML file. And also we can save that report file in our computer also. The same file, report file of that particular analysis, we can save it in our computer also. So where it can have to be saved, let me click on the here and then let me choose the Lending Institute folder. Let us create day 5 folder. Okay. Let us open this one. Studies report is there. Let us change that into structural analysis studies report or a structural analysis report. Just click on, see here what are the options it may be there. Just click on save, then click on save button. Automatically it may be get saved actually. So it's loading. So let me share the view of that report. See, this is the study report. So here study 1 is there, that is static stress. So when it has been generated, so date timing is there. Tolerance we had mentioned as 0.1016 mm. And then what will the mesh size property 2.54 mm we had already given actually, right? We had given this only. And then materials, aluminum, steel. The cutting rod is made up of aluminum and then large and small pin is of steel material. So what are the material properties? The material properties of the aluminum and material properties of the steel are there. Contact separation. So actually the contact set we have changed that into separation mode. Instead of bonded, we have mentioned it as separation. That's why it is shown as separation. And what are the load cases? The very first one is constraints. So what constraint we had fixed actually? So we had given it as fixed one constraint, fixed constraint actually. The fixed one is fixed constraint on the smaller pin. The next constraint is on these edges. These edges. So actually here the use Z only fixed. All other are free actually. And then fixed 3. That is also same. UY only fixed, all other are sorry, fixed 3, the circular one. Actually in that view Y is fixed, all other 2 are free. Fixed 4 constraint, that is on the connecting rod circular edge. So there we are fixed the same V, U, Y and Y direction. X and Z is getting free. Degrees of freedom would be there. And then the first load we had applied on X direction, that is 2000 pounds. And then the results. So what would be the minimum safety of the factor, maximum safety of factor, and then one misses stress, normal stress, everything, displacement, reaction force, strain would be there, contact pressure, and then the images of all these results. Images of all these results. The displacement. Okay, then come to the study 2. Study 2, mesh is there actually. Here the rigid body modes is in S condition, but in study 1 it is actually no. It is in no actually. It was in no. Study 2 is S actually. So we are applied for two things, but all other are same almost. Miss adaptive different material or same material materials is there. Separation is also contact sets of the separation. Fixed constraint 2 is there. Fixed constraint 1 only we have deleted that one. And then load we had applied one more load actually, that is force 2 on the smaller pin. Based on that results, what is the results actually? So few images based upon the results actually. So these are the things we can easily create it, right? So let us come to the Fusion 360. Okay. So what other ways we can go with? See, click on here, animate option is there. Let me click on animate option and then just play. So how the deformation would be? As like this, you can check it. So the play, stop, record button is there. Speed is normal speed. So if you need to, everything it can be applied actually. So this is stress. Let us go for the displacement. Click on animate. The same deflection might be there on every area. Only thing, the coloring of different parameters, coloring based upon the different parameters only will be give differ actually. So go to the strain and then play. Everything is same. Only the coloring it might be based upon the property. The color only maybe get changed. Even you can go ahead for some other options also. Show it out. Actually, by default, somewhat this is disabled. So actually, the report format is only web page format actually here. But actually, we can change it. So, or else you can even this report is also can go with the print option. Choose it, go with the print option. So the layout it should be in portrait mode. So this is the first page. This is second page. So as like this, you can generate more settings. Let us remove the header and footer. The paper size by default it is a letter. Let us choose A4. So hope this is fine now. Just click on save option. Let me ask, let me choose the day 5 folder. Structural study report. Just click on save. Day 5 folder is there. So now the PDF file is created. So fit one full page. Or I'll just go with to with for scrolling. See, 21 page report is there. So the same thing you can do it actually. See, for your students project and all, you can recommend this. They can do their project in Fusion 360 and they can easily share their report, get their report. They need not to type the report. They need not to prepare their own report. The report automatically will get generated. So this is the content node assembly. So both study 1 and then study 2 we have made it actually. So for study 2 also you can view the animation based results. You just activate this one and then click on the result. So here the deviation will be on both the axes because we are applied on both the bends, right? We are applied loads on both the ends, on both the larger pin and then smaller pin. So it would be there. The deviation might be. Let us go to this displacement factor over. So in this way, you can check your results. I think static stress analysis is over. Even what about, let us see our the status of generative design. Yeah, it is over actually. So here the option is open design. If we click on the open design option. So it's getting loaded now. So let us wait for a moment because it is getting loaded actually. So analyzing part, it usually it will take some time. The time is depends upon the internet connectivity. Can't open the design something went wrong when opening this in the statement. Now I again given open design, reopening the design. The internet connectivity should be strong because everything is cloud based. So the performance of this is purely depends upon your system also. The speed of your system depends upon the processing and then processor and then RAM, and also mainly on internet connectivity too. So how fast it is conducted, just like that. Yeah, now it is get open. See, our body is ready. Our generative design model is ready actually. See, I just roughly choose one design. So you may choose based upon your own. Okay, so based upon your requirement, not one actually, based upon your requirement, you can choose the design. I have chosen the recommended material. So that's why I chosen the same. And then I just considering the mass. That's all. So this is the model. Generally, let me click on the save option. Actually, it belongs to day 3, right? Let us go for Lengthy Institute. Day 5. It is not day 5. It should be on day 3. Just click on generative design model. So let me save this in on day 3. Just click on save. So this is my commitment. Actually, I missed on that day actually. So today we had completed. So this same model can be used for additive manufacturing. So this connecting rod is also over. So for this also we had export our result actually. Okay, any doubts?
So I think we have one question from the participants in the chat box.
Okay, so
Uh,
this is the option importing option, right, sir?
yes,
I
yes,
see.
yes, sir. Yes.
Okay, okay. So let me share that to you. So that is also possible here. That's no issue at all. Let me open a new design. File option. Click on open from my computer. These are the extensions you can open it. So where I can go, file, open. So open from my computer, let me choose, it is not, because if cloud means it would be in Fusion 365 only, right? So just click on open from my computer. That particular model can, it is generated in any other, as like that, any other software, as like Creo or some other model. So you can open these kind of files, IGS. So all these files, see AutoCAD files, alias files, and then Creo, OE files, STL files. stereolithographic files, step files, SolidWorks files. See, SolidWorks files and all you can directly open. If you click on SolidWorks files, all that file it may be shown here. So all these extensions is supported. There is no problem at all. See, CATIA V files, Inventor files, all this also there. Even you can grab from IGS files also. Any model that you can save it in IGS file in any other software. So that file also you can incorporate over here. So hope Indra, Dakubati, I clarify your doubts actually.
Yes, sir. Thank you.
Any other doubts from any other participants?
Dear participants, any other? I think one Mr. Sujit has raised his hand, sir. Sir, you can. I have unmuted you. Please talk, sir. Sujit, sir.
Yes, sir. Very good morning.
Very good morning, sir.
Am I audible, sir?
Yes, sir. You're all.
Yes, sir, you are audible.
Yeah. There are two things I got the doubt. Here, you have given complete information about this simulations. That is very good information you have given, sir. The first doubt is it all about the simulation studies is all about the cloud base or it is standalone?
It is a cloud based.
Means
It is a
complete from design, manufacturing or simulation. The software based is completely cloud based.
Completely cloud based. So what are the file you are going to generate or create, and then what will the simulation you are going to run? Everything is cloud
Sir.
based.
Acha, acha. So for that,
That's why I said that actually for running the simulation also you need the strong internet connectivity too.
okay, means for in what ways, how much RAM is required, sir, for means in a PC configuration?
Sir, the basic Fusion 360 needed, they are recommending of 8 GB RAM, sir, actually.
8 GB RAM, acha.
Yeah, you can see the system requirements of Autodesk Fusion 360 in Autodesk web portal itself.
Okay,
It is 8 GB RAM, and then Windows 10 operating system only going to be support over here.
means all this simulation will run in cloud only, not in computer, right?
Yes, sir. Yes, of course.
Acha, okay. Second doubt is you have
Sir, for that, I just clarify you one more thing.
yeah. Yes, sir.
Wait, sir. Let me share my screen.
Sir.
Hope you notice about the job status, right? So here,
Sir.
the first process is sending. In simulations, is sending, solving, receiving.
Okay, acha.
The sending the what are the study you had created to the cloud, solving there, and then you receiving from there.
Acha. Meanwhile, if it is disconnected, what will happen, sir? Again, you have to do.
No, if you that is job status, right? Even you can close your system and then you may left. Automatically the problem was sent and then it is solved only in cloud, right? So you need not to keep your system on. If the
Acha.
sending is 100% complete means you can switch off your system and then you can left. After a while you can come back and then you switch on your system. That's not an issue.
Because this is a small problem, it takes less time, but it is a very complicated problem. Then
it will take long time.
Yes, sir.
It will take long time. So only you have to check whether the sending is over or not.
Acha.
The sending you have to be complete. So then only what are the thing you had made it over in your thing, it will be move on to the cloud. The solving it will be happen in cloud actually.
Yes, sir. I got it.
After switch on your system, it will take some time to receiving. So that time it will take. Then you will open the results as like what we are seeing now.
directly it will show the results. That's right.
Yes, of course, of course.
Yes, sir. One more, the static analysis you have performed based on some we generally take steel, aluminum, titanium, means general our metals. Can you also take additive material for simulation, sir, with some filler we
So
give?
yes, sir, actually, I already shown that how to manage the materials. Based on
Material is
this,
okay, but with STL files, particularly related to additive filler we give different fillers, infill
okay.
materials. Sir.
Based on that, what you are
Uh,
asking,
can we do static analysis?
static analysis based upon the additive based material.
Additive based material, yes, sir.
Yes, 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 of course. So just you are going to change the material, right, sir?
Sir,
Here, there, so instead of aluminum or steel, you're
sir.
going to change the material of additive based material.
And that is library is available, sir.
Yes, of course, of course. That is there.
Acha, sir. Okay. Okay. Thank you very much. Thank you.
Thank you, sir. Thank you.
Sir, one more thing I would like to add to his question, sir.
Yeah, please, sir.
So when you say it's cloud, now everything is taking place in the cloud, is there any
No, no.
space limitation, sir?
Sir, actually, it is purely based upon the credits allocated for us, for our account.
Okay,
See, let me show that also.
okay,
So for knowing about our credit allotted for our account, you can grab it from here. So here there is an option for our profile may be there now. So
yes, sir.
that you can go for preferences. Just choose the preferences option. So I already said that there is some issue in my account, right? So I have
Yes,
some
yes,
three
yes.
accounts actually.
Mm-hmm.
So actually that thing you can check it from over here, tokens and cloud credits. Just
Okay,
click on tokens and cloud credits. So only actually I had received 500 credits. Now it is reduced to 489 after doing all these simulation parts. So you may also check it for which all the thing and how much cost it may
okay,
happen. See, for
okay,
rendering, it is cost around 1 credit. For rendering final quality render, it may cost 2. And then for generative design, it may cost around 11 actually. So we had used the generative design, right, sir? We had simulated one generative
yes,
design.
yes,
So
sir.
I had received 500 credits. Now that 11 is reduced.
Okay,
So now it becomes 489. So all this is purely based upon this credit. And then being an education account, you can get the credit unlimited.
okay,
Actually, for you people, it is unlimited.
okay, sir.
So based upon this only, it may be calculated, sir.
Okay, yeah.
So
Thank you,
here
sir.
itself you can check it how
Okay,
it is
sir.
handled.
And sir, how much would you recommend the internet speed for each system?
So 3 Mbps, sir.
3 Mbps. Okay.
Yes, sir.
And one last question, sir. This is from my side. So when we are talking about Fusion 360, when we try to explain people and generally, there are some standard softwares other than, Fusion 360, right? For
Yes, sir. Yes, of
modeling
course.
and all these things. So how, when we want to, uh, leverage the software in the sense, what kind of, how would you suggest now, how is it different from the other commercial softwares that are available outside? So in what way can, in other words, now how can we convince them now to move from what they are right now using to Fusion 360?
Yeah, yeah, I can get you, sir. Sir, first of all, for my let me share my point of view, sir. Actually,
Yes, please.
so hope you know about know about myself. I shared my experience too. Actually,
Yes, sir.
I have worked in different softwares. So both CATIA, Prio, and then Inventor, and then NX CAD. Also, I have some idea. So while comparing all these tools, I felt very comfortable on this Fusion 360. Why? Because it is earlier actually while I'm starting my career, I was very much comfortable on only Creo. See, if you give some model and then say you are please do this model in any software means I'll suggest only Creo. That is Pro. Earlier it was called as Pro actually. But nowadays I will suggest only Fusion 360. Why? Because of these changes means this is very user friendly compared with other all other softwares. Very user friendly, and then it is that you can easily grab from one workspace to another workspace easily. That is from design to assemble, assemble to drawing, and what are the changes you are doing in drawing that it would be reflecting in design. The same thing would be reflecting in manufacturing part too. The same thing it will be reflecting in simulation part too. Everything you can easily switch over from one workspace to another workspace. And one more thing is, it is a cloud-based tool. You need not to carry your files. You can easily simply save your files in your cloud credits itself. It is purely a cloud-based. And also, if you need to share your design to somebody means you have to download or you have to send that particular file, right? But here it is not needed actually. You just create a link for your model by share link, and then you can simply share that link alone. The file transferring also it is very easy. So everything, sir, not only this, lot and lot of things. See, actually, we had did 3 simulations right now in generative design and structural analysis, and also we are going to do structural analysis itself. 2 study we have created. So parallelly, I run 3 in Fusion 360. So within a short span, we may get the result actually. So
Okay.
the time taken for, by the software, that is also very less. So for your information, my system, it has 8 GB of RAM and only i5 process. Uh, I bought my laptop before 5 years, sir. Not before 5 years, even more actually. So in this system only, I'm running the Fusion 360 software. So the updated version only is running actually. So you need not go for higher configuration while compared with other. See, if you go for some other software with latest configuration, that is latest version means you have to you have to upgrade your systems. But in Fusion 360 is not like that actually. Not much needed of the configuration tool. So these are the key points. So if you need to add some more key points, it goes on actually. So a lot of things are there.
Okay, sir. Okay. Thank you very much, sir. Thank you for
Thank
sharing.
you. Sir.
I think we don't have any more questions, sir. Can we take a break?
Yes, sir. Okay, sir.
Yes, sir.
So let us join by 11:40, sir.
Yes, sir. 11:40.
Okay, okay.
Thank you, sir.
Thank you.
Dear participants, we will take a break for 15 minutes and we will resume our session by 11:40. Please note that 11:40 we will resume our session. After this session, we will have our valedictory program along with the overall feedback and other information related with the certificates and all. So please make yourself available during that time. Our session will start at 11:40. Thank you very much. Yes, sir, whenever you're ready, sir.
Yes, sir. Just now I also came out.
Yes, yes.
Okay, so let us start. So let me share my Fusion 360 screen. So now the same kind of only thing instead of structure load, we going for thermal load. So wait, let me open that file of me. Okay. So now, hope now you can see the Fusion 360 screen. So actually, this is the model of a radiator. So pipe is there, fins are there actually. So what are the elements here? See, water, it is some of the elements actually he has mentioned. So water is there, and then these are the fins, this is pipe, and then these are the fittings. So while going for thermal analysis, we can remove this water and then fittings. We are going to analyze about the deflections on pipe and then fins only. Okay, so we're going to study the deviations in pipes and fins only. Okay, properties of fins and pipe. So we can remove the fittings and then material which is flowing inside. Based on the material inside flowing only, it may be get transferred. So we can remove this two material and then we may consider these two. Okay. So first let us go for simulation. So let us change the workspace from design to simulation. So initially it shows some create study option. Sorry, new study option. So in this we have to choose thermal. We have to choose thermal, and then here we can go it for settings. So general it is steady one thermal, and then mesh. We will give the observed size by default is 10 mm. So let us consider that it as itself 10 mm. Just click on back. And just click on create study. So here instead of structure loads, only the thermal load is there actually. So that is the difference. Here we have to be conserve actually. See in loads instead of structure loads, here only one load, that is thermal loads. So all other are same actually. All others are same. So let us change the units to metric itself. Let's change to metric itself. So now we have to simplify the model. Now we have to simplify the model. So here in this model, we need some simplification process. So why? Because it is we have to remove these materials, components. What components are there? In model components, we have to remove the water and then fittings. That is not needed. So just go to the simplify option. So in simplify option, just expand the model components and then choose the component which is not needed for you for the analyzing. Right click the component. See your water is the component. Right click it and then choose remove. See by default, you please note down in the timeline there is No other options. In timeline, there is no other options. Just click on remove now. See, one is added. The water is removed. You have to remove the fittings also. Select the fittings, right click, and then remove. So here, these are the two objects we needed for thermal analysis. That is pipe and then fins. These are the two objects we needed. So we removed the unwanted particles. We removed the unwanted components. So based upon your requirement, you may use it. So here one more option is there, that is remove all except selected. So what are the material you need? You just select that one and then right click, and then if you choose this means all the other components removed from the analysis. Okay. So this is the simulation model. Just click on finish simplify. Just click on finish simplify. So if you come back to this means the simplified model, it will be appear on the screen. Simplified model only will appear on the screen. So now go to the materials. See here, materials option is there. Steady materials is there actually. See, by default, it is steel. Check all the fins, even the pipe. So 14 fins are there, and then one pipe is there. All the objects, all the components are made up of steel. All the components made up of steel. Now what I'm going to do is I'm going to change the material. I'm going to change the material. Excuse me. Sorry. So, okay, what we spoke, steady materials. So steady materials by default, it is mentioned as steel actually. So now I'm going to change the material, steady material. So actually design material is steel. So for steady, I'm going to change the material. So for changing the material, what I have to do is just click on the body one and then choose Control A. Control A, it is not possible, right? Okay, choose the first fin body and then Control A. So here in the component path, you just select it. In component path, you just select the body one and then choose Control A to select all the material actually. Okay. Okay, now all the material has been selected. Now what you do is just click on the same as model. In that, choose the drop down list box. Here the different materials are there. Different materials are there. Here I'm going to choose aluminum. And then just I have to change all the materials to the aluminum actually. Instead of steel, I'm going to change all the materials as aluminum. Just click on any other body. See, automatically all the steady materials of that object, of every object, is changed to aluminum. Just click on OK. Now we have changed the material from aluminum, from steel to aluminum. So choose the steady material. See, here the steady material is there. Just expand it. All the object of the material is changed to aluminum. Okay. So now what we have to go for? Loads. So the very first thing is we have to create the study. Then next we have to simplify the model based upon our requirements and based upon the analysis what we're going to perform. Then we have to choose the right material. Then we have to choose the right material. Then we have to go for loads. So here there is no constraints. See, while considering structure load, there might be you have to give constraints and all, but here there is no need of giving constraints. So directly you can go with loads because it is a thermal loads, right? So that's why we may directly go to the So directly you can go to the loads. So without constraint, we can go with the loads. So here, what I'm going to give it is, so first let us go with the temperature load. Just go with the loads, thermal loads. So here, what I'm going to do is, first let us apply the thermal load on the pipes. Okay. So for I have to apply on the pipe, right? So let us hide the fins. See here, the fins is there. Let me hide this one. So only pipes are there. Only pipe is there. So here actually we need to apply the temperature on inside surface. We need to apply the temperature on inside faces, but actually it is not possible to select, right? It is not possible to select. So okay, what I'm going to do is just to click on select all faces. Select all faces. Let me click on over here, and then just and create a rectangle for selecting all the faces of the pipe. So including outer and inner, every face will be get selected actually. Let me click on, let me create a rectangle for selecting all the things. Okay. See, let me switch off the fins. See, now 24 phases has been selected actually. 24 phases has been selected, but actually we need only inner phases. We need not to select outer phases. So here select all faces, it is enabled, and then we select the total object. So all the faces get selected. Now what I'm going to do is I'm just going to disable the select all faces, and then I'm going to, let me switch off the fin, and then disable after selecting the select all faces. I'm going to unselect the outer faces. See, just click on the outer faces. All the outer faces, it may be get removed one by one. See, let me cancel it because every time it, so just to switch off the fins now, then go into the thermal loads, select all faces, choose all the phases, or else you just go ahead with the front view. Then you can select all the faces. Now unselect this, select all faces. Now you pick all the surfaces which is not needed. See, automatically the number of phases is getting reduced. Come to the home view. Even this side surface is also not needed. Switch over to the view cube to the other side. See, only 11 phases. Only 11 phases are getting selected. So now I have to apply the temperature. So the temperature which is you going to apply, it would be on only inside surfaces, not on the outside surfaces. The temperature what you're going to apply now, that would be on only inside faces, not on the outside faces. Okay. So here actually by default it is in Kelvin because we have chosen the metric profile, right? So it may be indicated in Kelvin. So let me click on change units and then change that into Celsius, degree Celsius. And then let us give the temperature value, it might be of 75. Let us give the temperature value it as 75. So what would happen if you give 100? See, inside the material is water. If you the temperature value becomes 100 degrees Celsius, means what would be happen actually? Converts to steam, yes, of course. So that's why we are giving below that value. So we are giving the temperature value as 75 actually. So then the state won't change actually. So now we are applying 75 degrees Celsius on the inside faces of the pipe. Just click on OK. So in load cases, we had applied loads, that is one load, that is ambient applied temperature. If you Need to check means you just loads and then you expand it and then go with apply temperature. Just click on this pencil based icon edit tool. And then see only 11 faces are there. So the 11 faces are blue, highlight in blue in color actually. So just go to the front view. See all the outer faces are not get selected. Only the inside faces get selected. So just click on OK. Okay. Now we are apply the temperature. The next what we have to apply is radiation of fins, radiation between the fins actually. So that thing how we going to select that thing how we going to select actually. So we going to select fins, right? So just show the fins, hide the pipe. Now the pipe is not required. So just show the fins, hide the pipe. What I'm going to do is just go with the same loads, thermal loads. Now move on to the top view. Move on to the top view. Just go loads and thermal loads. Okay. Now select all the phases. Sorry. Just click on select all phases. Just click on select all phases and then select. Almost the same 140 phases has been get selected. But actually we need not to select this area. We need not to select this circular portion because the pipe may be there, right? So already so we need not to select this area. So what I have to do is let me choose the home button and then let us move to the again top. Let us unselect all phases. I need to remove the circular portion alone, right? You just select now. See, I'm creating a rectangle which should cover only the circular portion. Let me click on over here. See, automatically it is reduced to 84 faces. Now come back to the home view and then check. See that particular area. That particular area is not get selected. That particular area is not get selected. So you need not to worry about it. I just click on the home tab. So for here, I'm going to apply the radiation. So for radiation, here the load type, I have to change from applied temperature to the radiation. See what are the loads, thermal loads available here? Applied temperature, heat source, radiation, convection, and then internal heat. These are the different options. So let me choose radiation. So and then by default here the emissivity value and then or observability value it is 1 actually. Let it be the same itself. Just leave as like same. So don't change it is. And then ambient temperature is also 293.15 Kelvin. That also we can leave as it is. If you have to say that in Celsius means it is 20 degrees Celsius. So let us leave as like that itself. Okay, so 20 degrees Celsius, right? Just click on OK now. So we had applied the radiation. We had applied the radiation. So then what another load we have to apply? That is convection. That is convection. Okay. How bad that has to be get applied actually? The same thing. Just go ahead with loads, thermal loads. Just move on to the top view and then select. So before that, just click on select all faces and then select everyone, each and everything. So actually apply temperature is there. So just change it to convection and then select it and then select it. Now it will get selected. By default, it is 144 faces, but actually it is not there. You have to remove the circular portion. So just to create a rectangle which should cover only the circle. It should not cover the rectangle. Okay. So now it is reduced to 84 faces. Now we have to apply the convection value. Let us apply it as 5 watts per meter square Kelvin. 5 watts per meter square Kelvin. Just click on OK. By here the ambient temperature that is you leave as it is. Just click on OK now. So here we had complete the loads. Here we had completed the loads actually. So and then now we material is over, load is over. Now again we have to go with the contact set. Just go with automatic contact set. By default it has some value. Just leave as it is. Just leave as it is. Click on generate. So after that, just switch on the pipe actually. That is show the pipe. Okay, now the things are over. So contact sets are so over actually. So now we have to solve the analysis. Solve the analysis. So for solving the analysis, we have to. So before that, let us pre-check. Excuse me. So before that, we have to go with pre-check. See, pre-check, there is no error at all. Even in structure analysis, we have received some error actually, allowable errors. But here, that also not there. See, if you need to view this in mesh view, means you can toggle mesh visibility. So just click on here. The mesh has not been computed yet. Would you like to compute the mesh now? Yes. If you need to view means you just click on yes, or else it is not necessary, because if you click on solve, automatically it will mesh, then only it will analyze. The mesh will happen there itself. So if you need to view the mesh view means you can go here actually. You click on yes. Okay, just click on yes. Sorry. So now mesh is over. See the mesh view. Good one. Okay. Now we can go ahead with and solve. So just click on the solve option. See study one thermal model. Just click on the solve one study. Just click on solve one study. Automatically the job status window it will get appear. So here the stress analysis is going there. Expand it. So sending is over. 100% it is over actually. But solving is not yet started. So we have to wait for that. See, sending is complete. Solving is started. Okay. So let us close this window. Now what I'm going to do is I'm going to create one more study by increasing the fins, by increasing the fin sizes, by increasing the fin size. So for that, what I have to do? So I have to create a new study. I have to create a new study actually. Okay, how we can create a new study, and then not only new study, we have to alter the model. We have to alter the simulation model, because we have to add some materials on the sides of the fins. So for that we have to do some modeling portion, right? So whether we have to switch over to the design environment, or you can do the modification here itself. That you can do the modification here itself. You need not to go for design workspace. You can do the modification here itself. How it can be done? Here, for that only, here the simplify option is there. For that only, the simplify option is there. So we had created the simulation for simulation model 1. Now we going to go ahead with simplify option. There is an option called new simulation model. There's an option called new simulation model. Just let me click on that. See, simulation model 2 is getting created. So for this also, you need not to consider about the water and then fittings. Just remove those things. Right click and then remove. Water and then fittings. Just remove it. Okay. How to modify? Just switch off the fins. Move on to the top portion. So here you have to do the modification. Simply, you can easily do the modification here. Hope you can see the extrude option here, right? Where it is, where the extrude option it is, here it is, the create option. So just to click on extrude, select this portion, select this portion, extrude this. So let us give some value of, let us give some value of 80 mm. Just drag it, choose the value instead of 50, sorry, 80. So operation is join operation, just click on OK. The same kind of alteration you just apply on the all the four sides. So apply on the second side, this side also. Give the value as 80. What happened? Just click on OK. And let us reduce the extrusion value on the sides. Let me choose this one and then give the value as 65. Operation is join. Again, extrude option. Select the same 65. Operation is also join. Just click on OK. So now my model is ready. Only what alteration we had did? Only we had expand the fins. Just click on finish simplify. Just click on finish simplify. See, after click on finish simplify, now it has to select the new study. Now it has to select the new study. Let us go for the thermal. Just click on the settings. Mesh by default actually it is 10 mm. Just leave it as it is. Just click on create study. A new study is going to be created for this simulation model 2. Okay. Okay, what? Excuse me. Excuse me. So what are the thermal load you going to apply? The same load. What are the things we had applied on the previous simulation model? The same load only we're going to apply over here. Just go out with the expand the model components, enable the pipe, and then switch off the fins, check the materials. It is same as model. So we have to change it, right? So let us change, select this one, Control A, select these two, aluminum, just click on all the objects, components, materials are changed to aluminum, just click on OK. So we are simplified, we are apply the material, now we have to go to the loads, click on the loads, thermal loads. So just to click on, come to the front view first. click on select all faces and select the whole pipe. Totally 24 faces it might be get included, but actually we need to select only inside internal faces, not on our external faces. So unselect this, select all faces and then unselect the faces which is not required. Just click on the faces, automatically it will get removed. Just select this face also. So only 11 faces. Earlier also the same thing it happened actually. So what the temperature we had applied, so just code with the change units option, code with the degrees Celsius. Let us change the temperature value to, I think earlier we had given 75, right? So let us give 75 degrees Celsius, just click on OK. The temperature we had applied, and then we have to give the radiation and convection actually. So for that, let us switch on the show the fins and then hide the pipe. And then again go with thermal loads, move to the top portion, and then select the total phases. Sorry. So before that, just select or click on select all phases and then click select the whole thing, and then unselect the select all phases and then select the circular portions alone. Then automatically the cylindrical portion will get removed. See, by default here the bodies are 140 phases. If you select this means automatically it will get reduce it to 84 phases. So I have to change the applied temperature to the radiation. So by default the radiation is 1 and then temperature value is also the same 20 degrees Celsius. So let it be as it is, because in earlier conditions also we had applied the same kind of load, right? So if you click on degrees Celsius means it will show it as 20 degrees Celsius. So just leave the things as it is, okay? Just click on OK. So now the radiation is also applied. So again same thermal load, again move on to the top, go to the convection, just select all faces, select all. Just unselect the or select all faces and then select the cylindrical portions alone. Automatically the number of phases it might be reduced to 124, right? 84, sorry. 84. The convection value, what we had mentioned already, that's 5. So at the ambient temperature actually, just click on OK. So come to the home view. So all the things are done. So the radiation, convections, everything we had applied actually. So just go with the contact set options. Just click on automatic contacts. So solids by default submit cast some values. Just click on generate option. So now it is generated actually. So if required, we can go for mesh visibility or else it's not needed actually. So show the pipe. So go to the pre-check. Okay, everything is okay. Just click on solve. Choose the study 1 thermal simulation model 2. Just click on solve 1. So meanwhile, the study 1 is completed actually. See, the study 1 is completed. Study 1 for simulation model 1 is completed actually. So simulation model 2 only we have to check it. So simulation model 1, it is over. Okay, so now let me close this one. Or else you just go out with the result, the thermal results. Click on the results. By default, it shows temperature actually. So this is study 1. For this simulation model 1 actually, this is first model results. So here the temperature is there, heat flux is there, thermal gradient might be there. You can change it to degree Celsius also. And then you can grab the minimum and maximum value also. And then the report generation is also the same. The report generation is also the same. Just click on report. So model 2 is also there, but it is not yet over actually. So it's keep on running. See here, you can check the stresses. See, just let me go with the temperature, right? Heat flux, thermal gradient, these are the different options. Click on inspect and then click on create surface probes. Let me click on here. So I need to find the temperature at different places. Just place your cursor on the surface. Here that is 340. Then just create here. So wherever you need it, that you can easily calculate it. Okay, if you need to toggle off, this means just go out with inspect, hide all props. Just click on this. All the props will get removed. Just check the job status too. Yeah, that is also completed. It's getting received. So actually, this is also showing as a view results. Okay, click on view results. This is for simulation model 2 actually. See the transmission of the temperature in fins. So it is automatically get reduced, right? So it is reduced while compare with simulation model 1 actually. You click on here and then see the results. You may see the difference. Insert surface probes. So let us place here also. So this was for study 1, right? Okay, so let us go for simulation model 2. This is simulation model 2. So this is simulation model 1 actually. This is simulation model 2. So automatically you can see the differences, the temperature variations from one place to another place. Just go and compare. Just click on here. Just click on here or else. overcome. So only one study is there actually. So automatically the simulation model 1 is getting high while going with the compare option. So maybe in this simulation model 2 itself, if you create one more study means the study 1 and study 2 it will be get compared. So because we had created the simulation model 2, that is a different model. So that way the comparison chart is not appearing here. If you clone this study 1 here itself, right click clone the study and then let us change the temperature alone. Here the load cases it is. Let us change the temperature alone. Instead of 75, let us give it as 50. Click on OK. Now activate this one and then do the solve. Study 2, just click on solve and study. So the study 2 is there now. So for the simulation model 2 itself, the temperature, we had varied the temperature from 75 to 50 degrees Celsius. So now let us see what would happen actually. Click on close. So in this way we can do the thermal analysis also. Sir, any doubts on this, sir? After this, let us move on to the drawing portion. Sir, with the meshing of non-expanded plates, first study will not affect the expanded meshing of second study. Meshing of non-expanded plates will not affect. No, it will never. It will not affect.
I think we have a question from the participant. We have Dr. Narayan Rao. Sir, could you ask a question, sir? I have unmuted you.
Yeah, thank you. Actually, I have noted down many things following throughout the session. I have quite a lot of doubts because since you have applied the if you see in the software also, after the solve there is an ANSYS, means the results whatever you obtained, you are going to take it back to ANSYS further analysis.
No, sir. No.
Now the results whatever we have obtained, here there is we have not mentioned any mesh type, and also we have not mentioned what element type we are using for finite element analysis, because we are doing for these analysis finite element.
Okay.
In the element type also we have not mentioned in this one, or nowhere we have got a chance to mention that one. What type of element type we are using it here? I didn't get it. Means I'm writing it, but I have not seen it anywhere.
We are using you are asking about the material or some other else?
Element type. Materials I got it. Element type. What type of element type we are using to solve this one? Because we are doing the finite element analysis. Definitely it's a finite element analysis. What is the element type we have used it here?
Can't get you actually. I can't get your questions.
No. Since we are doing the finite element analysis, definitely it's a finite element analysis. We are performing based on that one. We have to define. Since we are defining the mesh size, definitely it will be of element type. What is the element type? I didn't get it, because all the complete the results of this one depends upon the element type and the mesh size. Okay, mesh size you have kept by default. There are different types of meshes are there, and also if you see in your software, there is further analysis for ANSYS. What is the reason for that one? I didn't get it. The software, the basic one.
Sorry.
Now, after solve, there is an ANSYS tab is there.
Yes, sir.
Yeah, means whatever the results you are
So
getting
that
it,
is
you want to
export
take
your
it.
set is set up to ANSYS. See here,
Yeah,
sir, I
means
am
you have done
creating
without ANSYS. Yeah, I got it. You have done without
here.
ANSYS.
Sir, you
But we
can,
are also doing in Fusion 360 complete finite element analysis only. Yes.
sir, in Fusion 360 itself, we had complete all the analysis part. So
Yeah,
if
that is
you
what
need,
finite element analysis. FEM itself. See, the whatever the analysis you have done, structural part or the analysis part itself, you have done is FEM.
we had completed
So
in
the
Fusion
doubt,
360.
basic doubt is what is the element type we are using it? Because in ANSYS we can
So
define the
in
element
Fusion
type.
360, the element type is a tetrahedral, sir.
Tetrahedron, so tetrahedron,
Tetrahedral.
tetrahedral. Oh, okay, fine. That is what we have. By default, it's a tetrahedral for all solid elements. It's
Default,
taking it.
yes, by default.
And also in the analysis part, you have defined a uniform temperature. But in radiation, we inlet and outlet temperature, we check it, and how the temperature transformation taking place from the pipes to the fins. That is a major important part we have. That is the part analysis we have, and I think we have missed it. Or either I have missed it. And by default, you have done a contact analysis. And in thermal analysis, the basic measure we check it in the contact part only. How the temperature is transforming from the contact part. And you have defined the uniform temperature across the pipe. The major doubt is, but in radiation, I think we are doing the inlet and outlet temperature, and what is the delta T is changing it. Can we get the delta T part?
The temperature changes.
Yeah, definitely temperature changes because you have defined a uniform temperature. If you see in your results also, the whole pipe is a maximum higher temperature. Okay, it's fine, but the major radiation is the inlet temperature and outlet temperature will be different.
Of course.
Yeah, definitely. But you have defined the uniform temperature across that one. And you have defined the inside temperature. But when you see the results, outside temperature of the pipe and inside temperature of the pipe are uniform. How is it possible? You have deselected the cell while applying the load, thermal load. You have only selected the inside layer and you applied it. But you solving it, if you see the whole pipe is of uniform temperature, the high end.
75 degrees Celsius, yes.
If you see the result, you can just only open that one. But you have only given the inside layer, inside pipe. But when you're doing the solving the analysis, the whole pipe is showing the same temperature. But in the analysis, you have deselected that one. If you see that the inside one and outside temperature is same, but you have only given the inside one and you deselected the outer one.
Transform from inside to outside only, sir?
No. The thermal analysis one we are doing it, we are checking the heat transfer coefficient.
The fluid will flow from one
From
end to
here,
another.
you're correct. The fluid from here and will go to outside. And you have defined the uniform temperature.
They rest actually somewhat, what it may be. So we are checking the transformation from inside the material to the fins. We are now
correct.
what we are checking is we are just checking about the variation of the fins. The fin, if you are in smaller size, if the fin or in bigger size actually. How the temperature is variation, it may be different from that part to that part. So for that only we have created two simulation model.
Now, okay, means you are doing it for the different fin sizes. How the temperature will transfer. That is the only thing. That is the only analysis.
What is the changes happen if the fin size changes actually?
With the larger size and smaller size, what we have.
Yes.
In-depth analysis is not done.
Yes, of course.
Yeah. Okay. In-depth analysis is not been done. Okay. It's for basic. No, I'm going to very higher line. So since you are following, very good, sir. Very good. Yeah, that is what the basic one.
So please understand that this is basically a introduction workshop. So it's
got it.
in-depth analysis.
Got it.
So,
because I'm writing everything. I have written the whole lot of pages.
Yes.
It's a very good.
Maybe no, once you get into the software and get used to it, you'll have more and more questions, and I'm sure you'll be able to answer. I know it's very difficult to know, put everything into a single session. That took a single one-day session.
No, that's
so, yeah. Thank you very much, sir. Yes, thank you.
Great. It's a great one. Thank you for clarifying.
Anybody else would like to ask? Participants? I think we can proceed, sir. Yes, sir.
Okay, sir. So let us move on to the drawing creation part, sir.
Yes, sir.
So let me share my screen. So let us go to our day one model or some other models are actually. Let me consider hook or lampshade, sir, for creation. Let me open the lampshade itself. Okay. So now we're going to create the drawing creation for this particular object solid model we have created here. Okay. So just go with changing the workspace. Let me click on here. And then let us move on to the drawing part. So here the drawing, it can be done either from design or from animation. Either from design or from animation actually. So just go with the from design. So by default, it shows some one drawing, that one dialog box, create drawing dialog box. So here the content, it may be of full assembly. And then the drawing, that is, we have to create a new drawing. So by default, it is create new only. The template is from scratch actually. So there is no default templates. So we have to create. So if you go with any company means they may have some templates actually. So that template we have to browse and then be selected. So let us start do as a scratch. So the standard, it may be of ISO, and then units it's also mm, and then the sheet size, in which sheet you have to create the drawing. So that you have to choose it. So let me choose A3. So by default is A3. You can choose some other sheet size also. Just click on OK. So if you click on ISO means this sheet will be there. If you click on ASME means automatically it will move on to the inches. So let me click on ISO and then the sheet size A3, click on OK. Automatically it will switch over to the drawing mode. Okay. So by default, so the drawing mode is open actually now. So drawing window is open. So by default, drawing view dialog box, it will automatically open, right? So here we have to choose the what view we have to create it. So by default this front view, right? So if you need to change to left hand side view or right hand side view, what are the thing it may be you need it. So based upon your need, you can change it over here. And then here the scale value is 1:10. Let me change that value as 1:5. And then in which style you need, whether visible edges or the hidden edges should be visible, or the shaded, that is look like a shaded part, shaded with hidden edges. So usually we will go for visible and hidden edges or visible edges. So these two only we will go actually. So let me choose visible edges alone. Let me click over here. Let me place over here and then click OK. So edge visibility, how it has to be visible. So tangent edge, it is off actually. So if you need to enable means you can enable. So click on full length as like that, you can enable it. Just click on OK. If you need to switch on the center marks and center lines also, it is possible. The whole center marks, the center lines of the whole, and then round extrudes, So for each and everything, so if you need to view on this means you just click on this one. Okay. Let me click on OK now. So now we have generated the one front view of that particular model. Now we have to projected view. Now we have to switch over to the projected view. Let me click on projected view. So for that project, creating the project view, you have to first initially select the parent view, right? So let me choose this as a parent view and then move your cursor where the projected view has to be created. So whether left hand side or bottom or right side, as like wherever you need it, you can create it. Let me click on here. So and then tick mark. So click on the same projected view and then let me click over here and then here. So and then click on tick mark. So I created 3 views. Okay. So let us change this view visual style. Just double click on this view. Actually, this is 3-dimensional view actually. So let us change it to shaded view, shaded style. Just click on shaded style and then click on project. See, you can view that particular part in a shaded style. So in this way, you can generate the different views. So if you need to create dimension piece, just go to the shortcut key D. Actually, dimensions over here is there actually. There's an option here, dimension is there. Let me choose D and then let me choose this edge. What is the diameter it is? Let me click over here. This diameter 50 and then this edge 270. Height from that particular end to this end actually. So actually it is not mentioned right manner actually because it is a free form, right? That's why. And then let me choose the distance between these two. 7.5. The diameter of the pipe actually is. So as like this, you can mark the dimensions, what is needed based upon your requirement can go ahead. And then if you need to create cross-section views, that is also possible. See here, the section view is there. Let me click on here and then select this particular based on which component may have to create the cross section. Let me choose this particular view and then let me choose from here to here, full cross section, midpoint to midpoint. Click on continue. So zoom it and then place the cross section view by here. So actually this is the full cross section. If you need to do some modification means here you have to do it. So full slice the distance, that is if there is offset cross section means that also it is possible. So you have to give some distance, but actually here let us consider it as a full cross section. Just click on OK. The cross section view is created. Actually the gap between the cross section lines, that is very less actually. So that's why double click on that cross section lines. Here the scale factor is there. By default is 1. Let me change that into 0.5. Let us change into 0.1 or else 0.2. Then it's fine. Just click on close. So in this way you can change the distance scale factor of that cross section lines. 0.3 and then here 0.5. So even the angle also you can change it here. By default is 15 degree. If you need to change that angle means that also you can do it actually. And then the pattern, by default it has some pattern actually. Standard pattern A and SA pattern only will be there. That would be available. If you need to do some modification means you can do it. And then I need to create a drawing for some specific area. That also you can do it actually by with the help of detail view. Let me click on detail view portion and then let me pick a point over here Just pick a point over here, sorry. Click a drawing detail view, select the view, and then let me pick a point over here, and then let me create a circle over here. So the name of the detail view is whether here you can give it actually, and then the scale value also you can modify it here. Let me click over here, and then click on OK. If you need to do some modification means just double click on it. The scale, let me increase it as 1.1:2. And then the cross section name, you need to do some modifications on it. Detail AS like that can represent. The 1:2 is scale factor of that particular view. See here also the section name is mentioned here. AA, and then the scale factor of that particular section view is also mentioned as 1:5. So in this way you can add the material, add the dimensions, different views. Even you can move the, see, even you can add the symbols. See, if you need to add geometric GD&T symbols, that also possible. So with the help of this feature control frame feature. See, if you need to add some straightness or flatness, whatever it may be, so you can add it. So here in this dimension, and if you need to add means I can add it actually. So I need second frame, that also possible. Like this you can add it. Just click on cancel. Here I'm not going to add it. And then if you need to give some surface finishing symbol, surface texture, that also possible. Here it is there. And then datum, if you need to mention the datum identifier, datum A, datum B, datum C. So because based on the datum only we may mark the feature for, that is we may mention the GD&T, right? Geometric dimensioning, all these things will be purely based upon the datums. So based on that we can do it. So these are the welding symbols, taper and slope symbols, all these that it can be done with the symbols. Even if you need to add some logo of your company, see actually here the image part is there. Actually here a title block is there. Just go ahead with insert image, insert from my computer. We show. Or else let me download. So let me place the image over here. Autodesk image is there. Cancel. So just go with insert image, insert from my computer. So choose the Autodesk logo, click on open, and then where it has to be needed, place it. So just let me zoom the area where it needed actually. Let me click over here. If I need to move, that means that also possible actually. Zero. Then let us go. Why isn't this at a 10 actually? Not at 20. Change it as 15. If you need to rotate, that also possible, but here it is not needed. Just place it as it is. Click on OK. So as like this, you can place the company logo also. And then if I need to edit the title block, just double click on it. So here the department, mechanical department, technical reference, Autodesk FDP, approved by Mr. Daniel sir, approved date. 23. Document status completed. Document type. Drawing file. Drawing number. So yeah, for everything you can do it actually. 001. So revision. This is revision number 1 actually. Or else you just mention, yeah, there is no revision at all. So this is the first drawing. So just click on finish properties over here. So you can apply what are the things it has to be needed here. And then if you need to add some text, so all dimensions are in, just click on text, click over here. Click on close it. So any kind of text you can incorporate over here based upon your need. And then just go out with the tables. So here part list is there. Let me click on parts list. You just place your, so before getting into this, let us delete some views. Let me delete, or else let us move, try to move. So now bring our table, insert parts list. So let me paste it over here. So here the parts list, see the item 1, 2, 3, quantity, number of quantities, one, all the items are placed it as each and every component placed only one time. So it is in 1 actually. And then the name, part number, it is mentioned as a name. So this is what file name actually it is, lampshade top, arm, and then base, all are file name. Actually, here the material is taken as a steel default material. So that's why it mentioned as steel. So if you need to change it, you can change it. That is not an issue. So I already show about the how to change the steady material of the any component. So in this way, you can bring your bill of material also. So just click on balloon option. See, I'm clicking on the balloon. Automatically, the balloon is also had created. Part number 1, part 2, number 3, as like that it is there. Okay, I have to convert this into PDF file for taking print out. See here, the export PDF option is there. Let me just click on the export PDF. Whether all the sheets it has to be incorporated. See, only one sheet we have created. If you need to create multiple, if you create multiple sheets for different drawing means that also you may convert that into a single PDF file. So whether all sheets or the current sheet is like that. So just click on open PDF also. So the line weights is also has to be converted. Just click on OK. So it has to be saved in that project folder. It should be on day 1, right? Because day. Okay, let it be in day 5 itself. And then save that into desktop Lend Institute day 5. This is drawing of lampshade. Just click on save. Just click on save. So let me share that PDF file also. See, we have created the PDF file. So close the bookmarks. So like this, you can see it. So here actually I had some one mistake actually. So actually this point it should be marked little bit above of the object. But I have marked on that particular area, on the edge of the component itself. That is a mistake we had done. So I think that's it. So now if you have any clarifications, it's open to all. You may ask.
Yeah, participants, if you have any questions, please raise your hand. You can also post your questions in the chat box.
Oh, thank you all, sir. Thank you all. Jyoti ma'am.
Yes, Jyoti ma'am, please ask a question.
Sir, your FDP, that representation was very brilliant and excellent one. I wanted to ask you, the question is that whatever the representation you have done, like different views and different substances, same can be used in civil, this application can be used in civil engineering as well as mechanical engineering. And second question is this used for 3D printing, that one for producing of the object, sir? Please answer
Okay.
this.
Ma'am, yeah, the same same software it can be used for civil purpose analyzing also, ma'am, actually. So hope you know about it. Each and every analyzing software for ANS is also, that is also used for civil analyzing too, actually. So as like the same, the fusion is also used for civil purposes too. So only thing what the material is going to be used. So you have to change the material, then you can apply it. That's all. And then for your second question, what it is? So sorry, what is the second question, ma'am? Jyoti, ma'am.
Can what are the designs that are drawn or created in this Autodesk Fusion 360 can be used for additive manufacturing? I mean, the 3D printing. So.
Additive manufacturing. Okay, sorry.
Yes.
Yeah. Ma'am, actually, initially, Thus, while creating the Fusion 360 software, it is apt for additive manufacturing. Later stage only, they are added lot of features now actually. So it is purely based for additive manufacturing now. Initially, it is created as like that. So still now it is supported to any kind of machines of additive manufacturing. It is very much supportive. So you can easily create for 3D printing also. So hope in generative design itself, we had chosen the type it as additive manufacturing. We didn't go for another manufacturing process. We chose only additive manufacturing only actually. For manufacturing method, we had used in additive manufacturing. So it is supported for additive manufacturing. The 3D part. 3D printing, it can be done here.
Yes, sir. Yes. So we have one question from the chat box from Dr. P. Ravikumar, sir. So he's
Okay.
asking, which is a good software, Ansys or Fusion 360?
So we can't say it as this one is good, this one is not bad, this one is bad as like that. See, every software has some unique features. That is my recommendation, sir. So I have used almost 7 to 8 softwares, sir, actually. I personally feels Fusion 360 is very comfortable for working actually. So that's why nowadays I'm using usually go with Fusion 360 itself. See, every software has some unique features. See, in Fusion 360, you can go for manufacturing. You can switch over to the freeform model, and then you can switch over to the sheet metal. What are the things you can for designing part that it can be done in Fusion 360, but that is not possible in ANSYS. But if you consider ANSYS alone means that it has some unique features while compared with Fusion 360. So we can't say this is good, this is bad. Where we can get, ma'am, no issues, ma'am. You can get training by ourselves itself, ma'am. If you need any training on this, you just contact myself, ma'am. I'll share my contact number also.
I think that'll all be, sir.
Sorry, sir.
I think that'll be it. Nobody else is asking questions. Yes, many of them are asking for the feedback link. Yes, dear participants, we will share the feedback link right after the validity program, which will begin in 10 to 15 minutes.
How is scope for this, ma'am? Hope you have attended all the 5 days of program. So each and everything what you are thinking about any kind of design means that is possible in Fusion 360. And also it is a cloud-based tool. So it has a big scope in future. Even the generated is also possible. Everything. What are the thing if you think means the all the things is possible in Fusion 360 in designing part. Not only in designing part, in manufacturing also. It's very much useful for manufacturing part too. So that's why I'm saying we have good scope in this one. I'm sharing my contact number and even mail ID also. In chat box.
The participants, please note that we will begin the validatory program shortly. Thank you for being patient. We'll also have a photo session. Photo session in the sense you can turn on your cameras and then we'll have a snapshot of all the participants that are here. Not now, not now. I will let you know, sir. I will let you know. Once the validity program starts, we will do that. Meanwhile, you can actually check your camera and then see if you are able to turn on it. Thank you.
And then this, one more thing, I had shared my contact number in WhatsApp also, my mail ID too. If you need the same kind of session for your students at your college premises, that also it can be done. If you have such a requirement, means you just kindly contact my contact number, wherever it is. That is not an issue. Wherever across India, that is not an issue. So if any faculty members are interested to conduct the same kind of program in at your college premises, you kindly contact us. So that's my both WhatsApp, my WhatsApp number and then my contact number is same actually. And I shared my mail ID also. Mohammed Baksar is showing some through online mode. I could not understand some exercise. Sir, if you have any doubts, you just ask, sir, no problem. Mohammed Baksar, you are saying that through online mode, it's not possible to understand some exercises, right? So for that only, I am saying that if you need offline mode also, we may conduct workshops at your premises, sir. That is not an issue. Is it audible now, sir? Mohammed Baksar, you are asking that through online mode, it is not possible to understand some of the exercise. So for that only, I am saying that if you need any offline based session, you just kind contact us. We may contact through whatever it may be for FDP or else for your students, we may conduct the physical session at your premises. Premises. That's not an issue. Pavan Kumar sir, the same thing I'm saying. Offline mode is also possible. If you have any such a requirements, you just kindly contact us.
So Riyad sir, I think whatever content we have planned is almost covered.
Yes, sir. We have
Okay.
covered all the things, sir, actually.
Great, great,
Not
great.
missed. So we added that drawing part also,
Mhm.
and then rendering part also.
Okay, that's great. That's great.
On that.
So I'm sure you might be having this attendance also for all the days from Monday to today.
Yes, sir, we did. We have it,
Yeah,
sir.
great. So sir, before starting the validity session, I
Yes.
just want to listen some feedback or suggestions from the faculty member side.
Yes,
Whether
sir. So we've
how
actually
was
included that as a part of the validated program, sir.
okay, okay,
Yes,
no problem.
yes. Okay.
I think many of the faculty members are requesting for feedback links, sir. If we have, please
Yes.
provide.
Yes, sir. We will be sharing it right after the validated program, sir.
Okay. Okay.
Yes. Okay, sir, we'll begin the session, sir.
Yes, sir, please.
Once again, good afternoon, ladies and gentlemen. It's my great pleasure to welcome you all to this valedictory session of this 1 week faculty development program on integrating Autodesk Fusion 360 in engineering subjects. So today we have gathered here to celebrate the successful completion of this program. And throughout this journey, we have witnessed the enthusiasm and the dedication of our participants, as well as our trainer. We are here to reflect on their accomplishments and to honor their commitment to enhance their teaching practices. So without further ado, let's embark on this momentous occasion and celebrate the impact of this FDP. So once again, I would like to welcome everyone, each one of you present here on behalf of the Department of Mechanical Engineering, Lendi Institute of Engineering and Technology. This day marks a significant milestone of our journey of integrating Autodesk Fusion 360 into our curriculums. We have learned much over the past few days. This FDP has indeed been a platform for us to explore new avenues and leverage technology to enhance our teaching methodologies. And I express my heartfelt gratitude to all the participants for their active engagement and dedication throughout the program. This afternoon, I would like to acknowledge the online presence of our dignitaries for the day. We have our Senior Professor, Dr. K. Sridhar sir, from the Department of Mechanical Engineering. We also have our Chief Guest for today, Dr. Rajesh Yadav, Inside Accounting and Making Specialist from Autodesk. And we also have our trainer for this FDP, Mr. Riaz sir, who has been instrumental in teaching us so much over this past few days. So we are so grateful to have you all here, sir. So firstly, as a convener for the event, I would like to give a brief report on this FDP. So this faculty development program was organized with an objective of equipping the faculty members with the necessary knowledge and skills to incorporate this Autodesk Fusion 360 software into their teaching practices. This program is basically aimed to enhance the engineering education by leveraging the potential of the software in design, modeling, and collaboration. I would like to acknowledge Dr. Rajesh Yadav, sir from Autodesk India Private Limited, who is also our chief guest for this day, and we will be hearing from him shortly. He was instrumental in making this event happen. We also had Mr. Bhaskar Rao from Design Labs Hyderabad, who was with us on the first day. He was unable to make it today due to his personal reasons. And Mr. Riaz Ahmad sir, the CAD engineer from Autodesk as well, was instrumental in taking all the sessions right from day one. We've learned so much from these few days, which includes several topics like solid modeling, freeform modeling, assembly with motion studies, generative design, PCB design, static stress and thermal analysis. So thank you all for taking time and showing us how the software works. I also acknowledge Autodesk India Private Limited for their support and sponsorship of this event. We have received a good response from the participants. I'm sure that they have gained practical experience and in utilizing this, at least have a basic idea on how to utilize this Autodesk Fusion 360, enabling them to enhance their the way of teaching and at large benefit the students. So basically, this program's impact is expected to extend beyond this FDP. It's not limited to this. And as the faculty members continue to implement this software into their respective courses, now we can develop a culture of now integrating the technology into our engineering education. So we express our sincere gratitude to everyone, right from our management, our head of the departments, the organizing team, the Autodesk team, and all the participants who made this event a memorable one. Thank you very much to one and all. It's now time to hear from our chief guest for the day, uh, Dr. Rajesh Yadav, sir. It's indeed a privilege to have him with us today. He is the Inside Accountant Engagement Specialist from Autodesk India Private Limited. He's among us right now, and sir, I would request you to kindly address the gathering. Over to you, sir.
Thank you. Thank you so much, sir. Though I don't want to take much longer time and I have no other things to say except a big, big, big thank you to everyone for, giving 5 days of your time. I know every educator, every faculty members has its own schedule, a lot of things you have to do. But still, for hearing patiently and you have attended the all sessions from Monday to Saturday, I'm pretty much sure all those sessions went well and you have got something as a takeaway so that you can transfer this knowledge to your students as well. So the very first thank you goes to Daniel sir because of him only this FDP could happen because he is continuously interacting with me from the last 1.5 months. I think more than 1.5 months. We had a lot of discussion, and then we decided, okay, we can go ahead with this. And the brilliant idea is because he wanted to make it in a big way, so that's why he has opened this FDP for all the other institutes as well. So because of this idea, I think we could achieve more than 250 faculty members for this FDP. And second, I would definitely give huge thanks. I appreciate Riyad's efforts because Mr. Riyaz has given a lot of time. I know sometimes it is a little bit challenging while taking the online session, but as we already say, this is the first program. It is not going to be the end. At the end of my things, I will also share my email ID and contact number. At any time you need any support, whether it is for students training or similar type of FDP, or you need our support to create a customized content for different subjects. As an Autodesk, we are always there to support you. So don't hesitate. I will be sharing my email ID and phone number. Just drop me a mail. I myself and my team members will definitely get in touch with you and we'll resolve all this. The ultimate objective is we want to make future engineers industry ready. So for that, that's why this is the objective of Autodesk. We always go for the top-down approach. Now, this entire FDP is completed. Now, I'm pretty much sure many of you will be confident. Yes, now you can at least start guiding about the latest technology to these students. Because for the students, you will be the first point of contact. For students, it is difficult to, get connected with us directly. So that's why we always try to connect with the faculty members at any time of requirement. You can take our support. In Hyderabad, my design lab partner is already there. I'm taking care of the entire India. So in case any college who is not there in the Hyderabad or somewhere else, please get in touch and we will always support you. As I already told you, not about the trainings, workshops or FDPs. If any of the students, any of your students doing good projects, any of your students need some type of internship, please get in touch with me so that we can always support you. That's all from my side. Now, I don't want to speech. I don't want to give a long speech. I simply want to hear some of the feedbacks, some of the suggestions. Anybody who want to give some feedback or suggestions so that we can make this program more effective from now onwards, please go ahead. Just raise your hand and you can unmute yourself and speak.
So we have Dr. Narayan, sir.
Yes. So, I think you are on
Basically,
mute.
head of the Department of Applied Engineering, and Applied Engineering is agriculture engineering plus automobile. And I'm from Vignan Foundation for Science Technology Research. That is, we call Vignan University, which is located in Vigna, Guntur. I thank first of all the organization committee and Daniel sir and Riaz Ahmad, and most likely, definitely, it's Autodesk. It's one of the great initiative which you have created, and without if you see my attendance, I started from 9:30 onwards. I'm the so it's a very great thing which we have initiated, and definitely this program is going to take forward to many. And Ahmad sir, very thank you very much. And this is a very great initiative because the way he has delivered the lecture, I think it's very excellent. I think I have attended many FDPs around this one and gone YouTube's many things. But the way the confidence he has shown in clearing and continuing the lecture is extraordinary. Anyhow, means he is a certified person on Autodesk. I don't have to say much, but he's excellent one. And this type of collaborative work we're looking forward. And thank you, Rajesh Yadav sir. And definitely we'll send our students to you. And we're looking this partnership to go ahead. Thank you, everyone. Thank you very much.
Thank you
Thank
so
you.
much, sir. Most welcome.
Thank you.
Thank you very much, sir. Anybody else would like to give a feedback for this event? Now, when we say feedback, it doesn't mean only the good ones. You can also share the
Yes,
point out
that's what I
bad
also want to
bad
listen
as well.
some suggestions.
Yes, yes. Yeah, we might have had some hiccups here and there, but yeah, you're most welcome to share anything. Narayan sir, yes, again.
Yeah, sorry, just missed it. Definitely next time when you conduct, please do conduct in offline mode. I will be the first person to come. And next time, definitely do charge it. Since you have done it free, anyhow, it's a good initiative. But next time, please do charge. I will come definitely, whatever the
No,
charge.
sir. Yeah, definitely. Out of these two requests, I'm giving you guarantee that one request definitely being going to be fulfilled. Next time we will be going for offline sessions. But yes, for the charges as an Autodesk education, initiatives, we are not allowed to take anything, sir. It
It's
will
great
be
thing.
free
It's
of
really
cost
great
for all
thing.
of you.
It's really great.
Thank you, sir.
Thank you so much, sir.
Anybody else, participants, want to share? Yeah, meanwhile, as you know, if you're thinking whether to share or not, I'll give you some time. Meanwhile, we can hear from Mr. Diaz sir. Yes, sir. Please share your experience over this past week. All the participants. Yes. Over to you, sir. Sir, you're not able to hear your voice. Yes, sir. Not able to hear your voice. No, sir, we're not able to hear you.
No, Riyad, sir, I think your voice is not coming to us.
Yes.
Is it okay now, sir?
Yes, sir.
Yes. Now we can hear.
Okay. Sir, first of all, I convey my sincere thanks to Mr. Rajesh sir and Mr. Bhaskar Rao sir. So they only give me the opportunity to give a session on this FDP program actually. And then my next sincere thanks to Mr. Daniel sir. So this is the first time I met you actually through call and then through WhatsApp text only. So you are giving me a very much support and then quick response for each and everything. Whatever if I ask, you are responding quickly. And then the organization is what organizing this FDP is very good, sir. Actually, so it's my point of view. And then my sincere thanks to all the participants. So spending all the 5 days program, I didn't expect this much of number of participants actually. So first day actually, what I had thought is before my system I set as like 30 to 40 or around maximum 50 would be there actually. But the first day itself, it will cross the 300 number of participants actually. So this credits goes to almost Daniel sir and the management of the Lendi College actually.
Yes,
So
definitely.
they are making this much of effort is a very great, sir. So organizing this much of people, so on a single shot. So this is a great thing. And then one more thing, I am express my sincere thanks to all the faculty members who are all attended here actually. So with their patience, so they are spending a lot of time actually. So almost 3 hours. So 3 hours with your planned schedules, spending half of the day session continuously for 5 days. So actually, I didn't believe. So whether I don't know whether I will be there or not as like that. So but you people are doing such a way actually. So really very thankful. Thank you. And then you people also ask many doubts. So I don't know whether I will satisfy your requirement or not actually. But somewhat I felt that I feel very happy with clarifying your doubts and clarifications and all actually. Some queries answering so your queries as like that. So thank you. So, and then one more request is you just planned this Fusion 360. I already said that. So this is that much of comfortable tool to handle any kind of designs. So you just carry the same thing to your students. So that is only one expectation from my end actually. So after this FDP, you just carry the same tool, same knowledge to your students, because the students has to be come up with, as Rajesh had said, the students has to be come up with the new technologies and the new way of thinking and as like that. So for that, this tool is yeah, one wonderful tool actually, that it can be used at anywhere. Thank you, sir. Thank you. Thanks a lot.
Thank you.
So
Thank you very much, sir. Yes.
heading to Riaz, I am sharing my email ID. If anybody wants to give some more suggestions for the upcoming event, and if any support is required from our side, please do write me a mail so that we can support you. I have already shared my email.
Thank you, sir. Yes, sir. As Jason was saying, our main idea is to take the software and and introduce it to the students. I personally have seen the benefit of this and what potential it has. So, and obviously, I've also experienced it live, when sir was sharing all those different aspects. I'm sure that this is a very small program, but yeah, but once we get into how we use the software, maybe we'll learn more and we'll get used to it. So, yes, sir. Thank you for your time and now sharing and teaching us software. So, yeah. So to formally end this, yes, sir.
No problem, sir. Please go ahead.
Yeah. So to formally end this bilateral session and this FDP, I would like to invite our senior professor, sir, Professor K. Sridhar, sir, to come and give his vote of thanks. Thank you, sir.
Good afternoon to all the delegates, distinguished guests, participants, and chief guest of the today's valedictory function, Dr. Rajesh Yadav, sir. Greetings from the Department of Mechanical Engineering, Indian Institute of Engineering and Technology. On behalf of the organizing committee, I would like to express my appreciation and thanks to all the participants of this 5-day international FDP on integrating Autodesk Vision 360 in Indian drawing, which was held during 26th June to 1st July 2023. This FDP is pleasure to the Department of Mechanical Engineering to host all the participants of the faculty development program through online platform. The participants are very enthusiastic and thankful to all the participants for joining from different parts of the country to attend the FDP. We have been fortunate to have some of the eminent persons from the team at Autodesk. I am sure that the participants must have benefited by attending this faculty development program. I am very much thankful to Autodesk team for sponsoring this event and making it a grand success. I would like to acknowledge and thank Dr. Rajesh Yadav sir from Autodesk India Private Limited. I also extend my thanks to Mr. Bhaskar Rao sir, CEO of Design Labs, Hyderabad, and Mr. Riyaz sir for the wonderful section delivering throughout the week. I acknowledge the unwavering support received from the faculty and staff members of the Department of Mechanical Engineering, Indian Institute of Engineering and Technology. My thanks also goes to all the people who have given their precious time to make this event memorable and success. The program chair, Dr. Satish Pujari sir, head of the Department of Mechanical Engineering, Indian Institute of Engineering and Technology. The convener, Mr. Daniel Siddharth Kumar sir, the advisory committee and organizing committee in Butler, Professor KCS Sekhar sir, Mr. Gangadhar sir, Mr. Kamesh sir, Mr. Jagdish sir, Mr. Appanal sir, and Mr. Ravi sir. I finally would like to thank all the participants who have given their valuable feedback about this faculty development program. We will definitely take your feedback and improving we will try to implement for the next section. Your encouragement is a constant boost for us. Hope you will have fruitful interactions in future also. The response for this FTP is encouraging, and we are sure that we would be organizing the next one very soon in short span of time. This time, Finn and Devin better will take into consideration and feedback of all the faculty as well as the Autodesk team. I once again thank everyone who contributed to this program to make this successful one. Thank you very much to one and all. Hope you will have fruitful interactions in coming span of time also. Thank you.
Thank you, sir. Now I would request all the participants, please put on your camera so that we can have a screenshot.
Yes, sir. Participants, can you please turn on your cameras so that we can have a quick snapshot? Please turn on your cameras. Please don't turn it off until we say so. Just give us a moment when we take pictures. Maybe the others also are there. You can turn on your cameras. It would be nice. You want to see the whole screen filled up with your pictures, photos. You don't want to have any blanks. Okay, thank you very much, everyone. Thank you. So, before we close with the national anthem, I have a quick announcements. First thing is that the feedback link has already been posted in the chat box. So, please fill the feedback.
And don't worry about the certificate. We will be, our partner, Mr. Bhaskar Rao, is releasing your certificates very soon.
Yes, yes. Thank you, sir. Thank you for that. We will also be sharing the recorded lectures to all the participants so that they can practice at their leisure. And you can expect the certificates in maybe 7 to 10 days. So please cooperate with us because there's a big number. So we need to dispatch them. So please make sure that you be patient and then we will send the certificates once you're eligible for that. So with that said, should we all rise up for the national anthem?
Yeah, sure.
What's the sound there? So with this, we have come to an end of the FDP. I hope that you have learned much from these past few days. So that's all from my side. Have a great day, everyone. Until next time, Daniel signing off now. Thank you very much.
Thank you, sir. Thank you.
Thank you, Rajesh sir. Thank you, Riya
Thank you,
sir,
sir.
and all the other participants. Thank you very much. Thank you.